Hello and welcome back to this course of videos on Node.js and Express. Now in the previous video we introduced the WebSocket protocol and its benefits for certain applications over the HTTP protocol. Now in this video we're going to show you that in a real working app. So this is the app you've seen in previous videos, but it's been enhanced to incorporate the WebSocket protocol, and I will just give you a quick demonstration. So I've already registered a couple of users in here, James, John and Jack, and these users are going to log in here and you'll see the WebSocket protocol in action. So I'm going to log in as James 1. This is a regular AJAX request. However, now that I'm logged in, all of my messages that I enter from here on in are going to be using the WebSocket protocol. So as we mentioned in the previous video, there's a single connection now with my server. It's not a separate TCP connection for every message that I send. I have one fixed pipe between my client and my server right now, which is sending these messages out to the server and then receiving them back. Now if I open up a new browser window here, and you can see there I've downloaded the page and I've already got the messages and the fact that another user is already logged on, and that was communicated. These items here were communicated via the WebSocket connection as well. And I would just add, I'm going to log in now as John 1 here, and you can see now now the John user has a direct TCP connection with the server, so John can begin adding his own messages here, and again adding to this list of messages using the WebSocket protocol. I can have one more user here. Again, as soon as I am making this new connection, the WebSocket, my WebSocket server is downloading these messages and the users that are online using the WebSocket protocol. I'm going to log on as Jack1. Username does not exist. Oh, it's actually Jake1. So I'm logging as Jake1. You can see again I have my third TCP connection in place, WebSocket connection, and now Jake can add something to the list. Now you can see that each time Jake updates, all the other two connections as well, everybody's in sync. And you see if I close down my browser here for Jake, we move on to John's page. You can see now there's only two online users left. If John closes his browser and disconnects as well, then I go back to I'm left with my James page and only my James user. If I refreshing it disconnects in the same way as closing the browser does, that logs off James, and this is the page that I'm left with. So that's the way the application works. So now let's take a look at the server and how all this is created. So I've actually used a module, an NPM module called socket.io for this application. Now you don't have to use the socket.io module. There is a WS module as well that you can use, which is simpler than socket.io, but the benefits of using socket.io module is that it caters for legacy browsers that don't support the WebSocket protocol, and it will fall back on the old school methods of the old school ways of doing bidirectional communication, things like long poll and comet, that kind of thing. So it will fall back on that for legacy browsers. So that's the benefit of using the socket.io module. So I've already npm'd my socket.io. If you look at my package.json, you can see I have my socket.io in my dependencies. So to look at using socket.io to build a WebSocket server. Now, what we're doing here, we're actually building our server in a similar way to what we did when we were using basic Node, before we were using Express, when we were just using native Node. If you remember using native Node, we required the HTTP module, and then we created our server with the create server method on the HTTP module. And then previously what we did is we did our server.on event listener. Remember, server is an event emitter. So on request, we actually, this with our basic, with our native Node, this was actually a callback function that we passed. The callback function was passed two arguments, a request and response object, and in the body of the callback function, all of the routing was handled directly within that body. I'm just going to cut away now and just show you an old video where we used that approach, and then we compared it against using Express. Now, when we the creation of our server in Express was much simpler. It was basically just this line here. We required it, and then we did constant app equals Express, because this returned the Express function, and that created our server for us, and our rights were then created with the use of the app, this app object here that's returned. I'm just going to cut back right now, and you can quickly take a look at those two, and then we'll get back to this. The next thing we did on the native Node side is we created our server using our HTTP module and the method create server. Now we're doing a similar thing on the Express side. We are saying constant app equals Express, and what is returned from that function is populated in my app variable, which is an equivalent of what was populated into this server variable when I ran http.create server. So now, on the native Node side, we said server.on, because server's an event emitter, if you remember. So we said on request, we would run this code. So on any request, on any type of request, we would run this code. Now this is where we start differing. So on this side, our app again is an event emitter. However, you can see what we're doing here is we are running a separate piece of code for each separate route. So you can see really what we're doing with these 3 lines of code is almost a hybrid of the two approaches of using Express to create your app with this single line of code, and then what we did with native Node, which was similar to this, but where this is actually a callback function with the request and response object. So this is these 2 lines here are exactly the same as our native method, but then when we do server.on, we actually pass app that was returned from the Express call. We're passing app as a second parameter rather than the adding the callback function that takes request and response as the arguments. So it's kind of a hybrid. Now, the reason that we're doing this and not just using the more streamlined method of using this simple line of code, constant app equals Express, to create our server, is that we need this server object. If you look down at this line of code here, the key code that actually instantiates our WebSocket server, because remember, we still need an HTTP server. I need an HTTP server. So for example, when we hit the submit button to register, or when we hit this button to log in as a user, we're still using our HTTP server. We need 2 servers. We need our HTTP server, but we also need our we need to upgrade our server, if you like, to a WebSocket server, which is what we're doing with this line of code. So you can see with this line of code here, we're requiring socket.io, and then with that object that is returned from the socket.io module, we're running a listen method, and we're passing it our HTTP server. So this is why we've gone this long-winded method to create this HTTP server using the old native node method, but we've actually incorporated our express module by passing the express object as our second parameter to our HTTP server to be used on request, i.e. any request that comes from the client. So we've created our HTTP server here. We're starting our server listening on port 8080 on localhost, exactly same as we did previously with the native node code. Now, and then back to this code, this line that we'd already discussed. So that's really setting up the WebSocket server. And in the next video, we'll be looking at how to send and receive messages.